Hey, what's happening, guys? Got the Arduino experimenter boards back that I showed you the preview of in the video last week from PCBWay, and they look pretty good except for one thing. This should be copper, and it's not. Let's take a look at the design files, see if I made a mistake. Yeah, so if we take a look at the board layout and we select this copper pour here, it is on the top layer, which is where it should be. And this is the top solder mask. In fact, if we go to the 3D view, you can see that should be right. Because what you're seeing is this color, same as this color. They are the same layer. So, well, I'm happy I didn't make a mistake, which, you know, happens quite a bit. So I'll have to see what PCBWay says about this. So I don't think I made a mistake. We'll have to find out what happened. Anyway, the boards look pretty good. I'm really happy with it, except for that one thing. So what I want to do now is I just want to check and make sure that I didn't make any other mistakes before we put this together. I don't know who's beeping at me. I think it's a soldering iron. So let's zoom in here. Got the multimeter set for continuity. So D4. Where's D4? Good. D7. Good. D8. Good. This should be 5, 6, 9. Good. Down here should be D2, D3, A0, where is A0? Oh, my meter shut off. Try that again. Okay. A0, A1, since these are just shoved in here, it might not be making a good connection. Where are we at now? A0, A1, yeah, we're good there. Then over here we have clock, which should be one of these. There we go. And this should also be clock, and here, and then data. All good so far. Now, here's our V in. This should be adjust in, out. Good. And that should also meet up with the plus, the positives here. I might have put those on 5 volt. We'll check that. Where is 5 volt? It is 1, 2, 3, 4 pins down. 1, 2, 3, 4 pins down. Yeah, because those are our digital pins. So, I think we're ready to assemble this. I've got these square header pins, and I'm going to put it together. Well, there she is. So we've got our input here. Got a reset button. This is the 7805, couple 1 microfarad capacitors for the input and output. We have 3 actuation buttons, each with pull-up resistors. We have 3 LEDs. You can see they are on the PWM pins so that they can have variable brightness. We have a couple extra digital pins broken out there, D2 and D3. A couple analog pins broken out. We have our 3 separate I2C ports, and we have an SPI port down here. So you can see thus is the aftermath of a soldering project. Whoop, got the Nano there. Make sure we get her all nice and seated in there. So let me write a little bit of code to test this, and then we'll come back and have a look. Yes, before you say anything, the 7805 needs a heat sink. I just don't have any right now. It'll be fine for now. Alright, let me write some code, and we'll see where we're at. This video is sponsored by PCBWay, and I wouldn't use them if they didn't make good products. So if we come down through here, you can see some of the capabilities that they have. We'll go to their advanced PCB capabilities. You can see that they can do up to 40 layer boards, the different materials they can use, maximum board size 500 by almost 900 millimeters, thickness up to 6 millimeters, minimum track 2 mil, minimum spacing of 2 mil, outer layer copper 7 ounce, inner layer copper 7 ounce. You know, they can do pretty much whatever you want them to do. They can even go as far as impedance control if you're working with high frequency items. So very, very cool. I'm going to scroll down here through some of the other capabilities they have, in case any of them are useful to you. PCBWay.com. Check them out. There she is. I actually kind of like it. Now, before I plug it in to show you, something occurred to me after I built this bad boy. I should have put a potentiometer on here. So, perhaps version 2 will have a potentiometer. Anyway, I wrote a little code to test the buttons. We have a 12 volt adapter here, which I will show you when I bring in the meter. There's the meter. .12 volt adapter. Getting 12.25 volts. And we'll plug her in. It goes just in out on the 7805, so if I go between the out and the ground here, you see we're getting 5 volts. So all is good. Now, let me zoom in down here for you. And turn out these overheads, which make things a little hard for you guys to see. Okay, so there we go. There is the OLED printing out a happy hola for my friends who habla de español. Now, we have button D4 to ground. I'm going to turn on one light. There we go. D4, if you press D4 is now high. It has a pull-up resistor, which, let me show you. So if we read D4, which is right here. Oh, you probably need to see the meter too. Let me zoom out. So D4 and ground, you can see we're getting about 4 volts. So that is high. And we press the button, and it causes that LED to flicker. Now, see where it says Ola? If we press D7, it says D7 is low. If we press D8, it should cause these two to flop back and forth. There you go. So we got there. We got D7 is low. We got there. She's all working. Pretty happy about it. Let's test the reset. Here you can see it says Ola. Press the reset. You can see it is resetting through the Adafruit. Yay! Success. So I'm going to put a link down below to where I've shared this board so you can download it from the PCBWay website and play with it yourself. If you guys want me to do a version 2 with a potentiometer and any other suggestions you have, put them down below and we'll add them to the board. I would like to thank our sponsor, PCBWay. Awesome boards you guys make all the time. Good quality, super fast service. You know what? You just can't beat that. Alright, if you enjoyed this video, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. We're almost at 100,000. I got 9 more of these. I ordered 10. I'm going to send them out randomly to my patrons. That's it. I'm out. Peace.